In 7.5, we're going to move on and talk about division properties of exponents. And this is awesomely the final property that we're going to be discussing in this chapter. So you are almost done. As always, please write your objective. So the objective for this section is to use and apply exponent rules of dividing terms with a like base. So let's do a little discovery, okay? Just like we did with all the other properties, I want to help you discover this on your own, to empower you to understand what this rule is. So for each expression, expand, cancel, and then write the quotient using one base. So x to the 5, well, we've already talked about that that's the same as x times x times x times x times x. X cubed is just x times x times x. And then if you recall, when you have the same thing top and bottom, you can start canceling. So I'm going to cancel off 3 pairs of these. And what I'm left with is x times x, or x squared. All right, what about with the 3's? Well, 3 to the 7th power is just going to be 3 times 3 times 3 times 3 times 3 times 3 times 3. On the bottom, we have 3 squared. And again, let's do the same thing. So I'm going to cancel off 2 from both the top and bottom. And what does that leave me with? Well, that leaves me with 3 to the 5th power. So let's think about 5 and 3. How does that relate to 2? 7 and 2, how does that relate to 5? And I hope pretty quickly you're going to recognize that what the rule is when you're dividing is you subtract. Okay? So, and kind of makes sense. If multiplication is linked with addition, division would likely be linked to subtraction. Okay? So again, in your notes, you have room to write it in words. So talk about the division in words using algebra, which is exactly how I have it written on the board. And then you have spots for other examples. Okay? So take a moment to do that, and then let's go on to practice what this looks like. Okay? So, simplifying the expressions. So A is going to be the most basic case, the awesome case. X to the 8 divided by x to the 3. Again, division is linked to subtraction. So 8 minus 3 just leaves me with x to the 5. All right, for B. Well, for B, we're looking at m to the 2 divided by m to the 5. So 2 minus 5 leaves me with a negative 3. N to the 4 divided by n to the 3. 4 minus 3 is an n to the 1, but again, you never really need to show that 1. Now, here, as always, we need to remember we don't want to leave things with negative exponents. So what that means is I'm going to take that m to the negative 3, I'm going to get rid of its negative attitude by moving it to the bottom, okay, moving it away. And that's going to be the most simplified form. All right, so let's get some more practice in on this skill. So y to the 5 divided by y to the 4. Again, 5 minus 4 leaves me with just a y to the 1, but again, you don't need to show the 1, okay? You can just leave it as y. D to the 3 divided by d to the 9. Okay, that is going to end up being 3 minus 9 is a negative 6. It's going to have a negative attitude, so I'm going to move it down. Now, you might be noticing a pattern here, okay? Notice that there were more on the bottom to begin with in the original problem. So that's where it ended up in the end. So when it's pretty straightforward like that, maybe you're going to start recognizing that when you're getting a negative exponent, maybe you just know that you're going to move it downstairs right away anyway. And you can just write it as 1 over d to the 6 and bypass that d to the negative 6, okay? So you can learn some tricks along the way to shorten your work sometimes, okay? But of course, only where you feel comfortable when you start recognizing these patterns. So how about this next one? K to the 6 divided by k to the 1. 6 minus 1 gives me 5. J squared divided by j to the 5. 2 minus 5 is a negative 3. Then, of course, negative attitude, we need to move it. So again, just like I was saying, because you started with more in the denominator to begin with, that clues you in that that's where it's going to end up, okay? If it's negative up top, you know right away you're going to be moving it down anyway. All right, what about this next one? For D, a to the negative 3 divided by a to the 5. Negative 3 minus 5 more is a negative 8. B to the 7 divided by b squared. 7 minus 2 gives me 5. I have something with a negative exponent. We need to get rid of that negative attitude. So I'm going to move that a down so it can have a positive exponent. All right, for E, x to the 4 divided by x to the 4. Now this one, 4 minus 4 would leave you with 0, x to the 0, which would turn into 1 anyway. So this is one of those strategies that if you have the same thing top and bottom, instead of showing anything, I just kind of get in the habit of slashing it out. It's going to become 1 anyway, which means it's not going to influence anything. Okay, so just a little kind of shortcut for you. If you end up with the same thing top and bottom, you can just slash it out, okay? Just like when we were doing examples up above. Negative 1 minus negative 5, okay? We have y to the negative 1, y to the negative 5. So just like I said, we know we're going to end up subtracting them. But you have to subtract them very, very carefully, okay? So negative 1 minus negative 5. So again, be very careful with that. Negative 1 minus negative 5. Subtracting a negative is the same as adding it. So that is actually going to become 4. Okay? So this, we're going to get a y to the 4. Then z to the 8 divided by z to the 1. 8 minus 1 gives me 7. Now, maybe you're not thoroughly convinced. I mean, you see the calculator gave you that y to the 4, but maybe you want to understand why it works that way, okay? So I'm going to focus on those y's for a moment, okay? Those y's have negative exponents, correct? So those negative exponents, what if I moved them, okay? So that y to the negative 5 is going to have a better attitude up top. The z to the negative, or y to the negative 1 is going to have a better attitude on the bottom. Okay, so notice, when you move it right away to alleviate any negatives, that 5 minus 1 gives us the same 4 that we ended up with. So that's another strategy, okay? If you don't want to end up subtracting negatives and stuff like that, feel free, move those negative exponents around first, then subtract, and that might be a whole lot easier for you, okay? So just like in D, if I had moved that negative 3 right away, if I moved it to get a positive attitude, notice it's much easier to see those creating that 8 in the denominator, okay? So again, feel free if you want to take that extra step, if you need that extra step to show yourself what's happening, feel free to take that time to do so, okay? So back to another geometry example. The area of the rectangle is 72a cubed b to the 4. What is the length of the rectangle? Well, we've been talking about area a lot. Area is length times width. Well, we want to know the length, okay? Well, if I divide by the W, that's how I get the length. So to get the length, what I'm hearing is I need to take the area and I need to divide it by the width. So 72 divided by 6, 72 divided by 6 is going to leave me with 12. A to the 3 divided by a to the 1, 3 minus 1 leaves me a squared. B to the 4 divided by b to the 1, 4 minus 1 gives me b cubed. So when I do the math, I'm going to get letter B as my answer for that problem. All right, so we're going to do a little discovery again. So simplify the quotients raised to a power by repeated multiplication. All right, so what does that mean? Well, that means this is going to be x over y times x over y times x over y, okay? X over y cubed, I'm seeing that 3 times. So on top, x times x is x cubed. Along the bottom, y times y is y cubed. And I'm guessing this is kind of what you expected to happen, okay? Let's take a look at the next one. If I'm squaring this, it means there's 2 of them. So I'm getting 4 squared and x to the 3 times x to the 3 on the bottom. 3 plus 3 gives me 6. So I think what's happening again, I think it's pretty intuitive, is when you're taking a quotient to a power, just like a product to a power, the power is going to influence everything, okay? So in this top one, that third power influenced everything, the x and the y. This squared influenced the 4 and the x cubed. Okay, so to write this rule is influencing everything inside that parenthesis. So in words, I want you to describe that. Okay, the algebra is what I already have on the board for you. And then you can make up an example to show this property. So, looking at some more examples of this. Okay, so looking at all of these examples, 2p over 3 cubed. So that cubed is going to influence everything inside that parenthesis. Okay, so I'm going to have 2 cubed on top, p cubed, and 3 cubed. All right. Then this next one, again, has 2 ways you can go about doing this. You can square everything. So here, 2 squared is 4. X to the 6 squared, power of a power, means you multiply. Y to the 4 squared, so power of a power, then x squared. And now I have x to the 12 divided by x to the 2. So that's going to leave me 12 minus 2. That's going to leave me with an x to the 10. But again, just like I said, there is more than one way that you can do this. What if I wanted to simplify within the parenthesis first? What if I want to simplify that right away to x to the 5? Well, if you notice, the awesome thing is you end up with exactly the same thing. So I find it's usually easier if you remember to simplify within the parenthesis first. But if you happen to forget, No, you're getting the same thing anyway, okay? It's just often easier to take the blue route, to simplify within the parenthesis before you apply that power from the outside. Now let's look at the other side of this, okay? So again, we're going to apply that -3 power to everything, okay? So I'm going to have 2 to the -3. Power of a power, 6 times -3 is a -18. Y to the 4 to the -3, power of, oh, I'm sorry, that should be an x. The power of a power on the y also is going to give me a -12. Now again, recognize now I have a ton of negative exponents, okay? So I'm going to move that 2 down to get a positive exponent, the x down to get a positive exponent, and the y up to get a positive exponent. Then, of course, 2 to the third, we know is just 8. All right, now I want you to notice something that happened here, okay? So what happened here is starting with the negative exponent, notice everything ended up flipping its location. The 2 came down, x came down, y went up. So you can apply that negative exponent throughout, but there actually is another way to think about this, okay? That negative exponent, if you have a negative exponent applying to a fraction, okay, what it's doing is it's going to end up flipping that entire fraction. So what some kids prefer to do is take care of that negative exponent first. Don't distribute it in. Get rid of the negative by flipping the fraction, okay? And you saw that that happened. To go from here to here, to get rid of all the negatives, or I'm sorry, to go from here to here, to get rid of all of those negatives, that's what you had to do. You had to flip everything where its location was, okay? So you can deal with that negative first, then apply the positive power to everything. And that is a perfectly legitimate way to do it. Okay, again, alleviate the negative first, then apply that power within. All right, so speaking of different ways of solving these, I've kind of touched on this already, but describe 2 different ways to simplify that expression. So recall, there are 2 ways. I could apply that power of a power first. Okay, 8 to the 7 cubed, power for power, multiply them to get 21. 8 to the 5 cubed, power of a power, multiplies to 15. Now I use my division, 21 minus 15, to get 8 to the 6. So remember, that's one way. The other way is you could simplify within the parenthesis first. So 7 minus 5 leaves me with 2. Now, power of a power, 2 times 3, gets me that same a to the 6. So again, just an awesome strategy that I do want you to recognize that these can be solved in various different ways, okay? And as long as your way is mathematically sound, it is going to be acceptable. Just usually one way may be easier than another way. All right, during 1 year, Honduras had a population of 7.33 times 10 to the 6 people. The area of Honduras is 4.33 times 10 to the 4 miles squared. What is population density? Okay, so density, or population density I should say, is people per mile. Okay, how many people are there per mile? So that's how I'm going to write this. 7.33 times 10 to the 6. We have the number of people, and then divided by the number of miles that we're talking about. So again, just referencing scientific notation. This works very similarly to the multiplying side of scientific notation. Okay, so just like when you're multiplying, you first deal with these normal numbers out front. And those normal numbers out front, in this case, we're dividing. So I just take 7.33 divided by 4.33. That's going to give me approximately 1.69. Okay? And then the powers of 10, we're talking about our division property. So we're going to subtract 6 minus 4 leaves me with a 2. So there are going to be that many people per mile. Okay, and again, very, very similar to when we were multiplying them together. So you just divide the normal numbers up front and then subtract the exponents when you're dividing in scientific notation. Just like all the other notes, please, next on your list, make sure that you look at the learning objective in the summary. So remember our objective, to use and apply exponent rules to divide terms with a like base. So I do want you, please take a moment to write out a few sentences for me on stuff you learned, and then also make sure that you rate yourself on that learning scale.